If you remember in our previous lesson, that is Introduction to Programming and Data Structures, we had talked about two most important features of C programming. Those were portability and less lines of codes. Let's explore some more features of C programming. Have you ever wondered why a company like Google, for example, has separate departments for carrying out different tasks for the same job? Like suppose, if their job is to develop a software, then there might be a separate department for requirement analysis, a separate department for designing phase, or maybe a separate department for testing phase, etc. etc. What do you think? What is the need of making so many departments for the development of a single software? Think about it. One day, I typed in Google search box highly effective study habits. And one of the results that popped up is this. Don't attempt to cram all your studying into one session. Successful students typically space their work out over shorter periods of time and rarely try to cram all of their studying into just 1 or 2 sessions. That is what I would like to emphasize about. These two examples have something in common. To be successful in some task that you want to accomplish, the best idea could be to divide your task into smaller tasks and then work on them separately. The similar idea is adopted by the inventor of the language. He defined the language as a procedural language, which simply means dividing your gigantic program into much smaller programs called procedures or functions, so that we can easily work with them. So everything in C is nothing but set of procedures or functions, and this is the main feature of C language. There is a distinction between high-level language and low-level language. Here, high or low simply points to the degree of abstraction. Abstraction means hiding system-level details. Therefore, high degree of abstraction means less efforts to the user, or you can say more user-friendliness, as we won't have to worry about what is happening inside. Example could be simple text editor. You just typing out the text and when completed, hit the save button without even worrying about how it is getting stored, where it is getting stored, etc. etc. This is called a higher level of abstraction. On the other hand, lower degree of abstraction means more efforts to the user. In this case, you have to know each and every internal details about the computer. Example of high-level programming languages are COBOL, Fortran, C++, Lisp, Pascal, Prolog, etc. etc. And on that of the low-level languages, assembly language. There is one more level which is called middle level, which is neither high nor low. C language is called middle level language because it does make programming simpler for human beings. But then on the other hand, it also allows us to access system level features such as direct access to memory through pointers, bit manipulations using bitwise operators, writing assembly code within C code. Because of these unique features of C, C become a popular language, or you can say a popular choice for developing both system level applications like kernel, device drivers, operating systems, etc. and various software applications like games, editors and other graphic rich applications. These things are called system level features. Now C offers wide variety of built-in functions, standard libraries and header files. This makes programming a cakewalk for programmers, and that is obviously a great advantage. Okay friends, after a long conversation on the feature of C programming that we had up till now, let's jump to an example to give you an idea about how a C code looks like, and we will also explore what does each line mean in the code that we wrote. Let's try to make this session even more dynamic. I would recommend you to please download CodeBlox IDE to execute code on your own. Because as I already told you, programming and data structure becomes more interesting when you get your hands little dirty. CodeBlox is an integrated development environment that helps you in creating C programs efficiently. You must follow the link in the description below to know more about how to install CodeBlox in your computer. Now we are going to execute a very basic C code in CodeBlox, and I will explain to you what does each line depict in the program. In the first line I had written comment using /. Compiler usually ignore the comments. They are meant for the users, or you can say developers, to help make code better understandable for them. As I had written on the top that this program will print the output NESO Academy onto the console window. Console window is just a black screen that you will see in a moment. Next I had written #include stdio.h. Let's try to understand what does it mean. #include. This so-called command written over here is called as preprocessor directive. Now the common question that pops up immediately is, what is preprocessor? Preprocessor job is to replace the contextual content, which is actually followed by hash symbol, with the actual content. You had simply written hash include stdio.h in your code, but preprocessor actually replaced this line with the actual file stdio.h. Actually, before the compilation process begins, preprocessor does its job by replacing those texts, which are followed by hash symbol in the code. As the name itself suggests, preprocessor, which means processing done prior to the actual compilation. Previously, what you have is the source code. The code that I had written is called source code, which is now converted to an expanded opcode, or you can say expanded source code. Because of the preprocessor, we had replaced those statements which are followed by hash symbol with the actual content of the files. This obviously increases the size of the actual content and therefore called expanded source code. After that, it sends the code to the compiler, and compiler does its normal processing of converting source code to machine code. Therefore, hash include stdio.h simply requests the processors to include the file stdio.h. Now what does stdio.h means? stdio.h is standard input-output file with .h extension. This file with the .h extension is called header file. Header files usually consist of prototypes, or you can say declaration of the functions that we need. For example, stdio.h consists of declarations of functions like printf and scanf. Printf function is used to print the contents, whatever is there inside its parenthesis, and scanf is used to take user input at runtime. Including the header file is important, as you need to tell that which functions you are going to use in your program. Next, I had written a weird looking expression, int main, followed by curly brackets, and inside them you have some statements written. Before explaining you what does it really mean, let me give you a brief overview about what is function and variable. Whatever the code you write in C, it always consists of these two important elements. C functions consist of group of statements that are intended to solve a particular problem. On the other hand, variables are the entities used to store values which are used during computation. In our example, we have function named main, and the statements of the main are enclosed within these curly braces. Here the purpose of main function is to print Naso Academy as output. Note down one thing, you may have several functions inside your program, but the entry point from where the actual computation begins is the main function. Compiler actually look forward to this particular function, and it is the starting point of your program. Now the basic syntax of defining a function looks like this. You have a return type, then you have name of the function, then parameter type, name of parameter, parameter type, name of parameter, enclosed within these brackets. These are called parameters lists. And inside you can say you have some set of statements which are followed by these curly braces. Here in our example, return type is int of this function, main. Int is a short name of integer. That means your function, after completing all its statements, will return an integer value. You can see that the last statement that I had written over here is return 0. It indicates if your statements completed successfully, then return integer 0 and exit from the function. As if something else goes wrong, it will return some other integer other than 0. I will explain you in details about the functions in upcoming lectures. For now, this is enough to know. In function syntax, after return type, you have to specify the name of the function. It can be any name of your choice, but in my opinion, it is better to choose a name which will give you a clear picture about what your function will actually do. Like if a function is meant for performing addition, then the name add looks more sensible. It improves readability. But there is no hard and fast rule. You can choose any name of your choice. Main function is predefined. Okay, you cannot change that name. Main is predefined already. After the name of the function, you can see some lists of parameters which are enclosed within these round brackets. These are called the inputs to your functions. In our example, main function doesn't have any parameters. It is mostly defined like that way. But if you want, you can add parameters argc and argv whose values is being provided at runtime using command line arguments. You don't have to worry about it right now. We'll talk about them in details later. Now, let's come to the main content over here. Printf, Naso Academy and all, return 0. What does it really mean? Here, we have a function called printf, which has one parameter closed within quotes. If you see carefully, I haven't put any curly brackets after this printf function. I simply put a semicolon over here. The reason behind this is that this function is predefined already somewhere in stdio standard library, which is the library containing definitions of many functions like printf. The advantage of such a library is that we won't have to write down the codes of functions again and again. Instead, we simply call them whenever needed. So we just have to call the function instead of defining it once again. Note, in comparison with the definition of the function, everything is as it is when you are calling a function. But at the end of the closing bracket, you have a semicolon and won't have curly brackets after that. Using printf function, you would be able to print the output Neso Academy on the console window. Okay, let's execute the code. You simply click on build and run button over here, okay, for the execution of your code. If you're first time writing the code, then you have to use this build and run. Let's click on it. Here you can see the output Neso Academy is printed, right? With the information process returned 0, which simply means that your program completed successfully. Note, here because we are first time executing the code, therefore build and run both are required. Build actually asks the compiler to build the machine code for the source code we had written, and run simply runs the code and produce the output. Run button is available over here. If you're second time executing, you simply have to use this run button. If you're not making any changes to the code, then clicking on the run button is sensible. If you made any changes, then you have to build it again and run. There is one more important point I would like to mention. As we had learned that we write #includestdio.h to include the standard input-output header file. And I told you this header file contains the prototypes or declarations of the functions, like printf. And I also told you that C standard library consists of the actual definitions of the functions like printf. Then one important question I would like to address is why we require different files, one for storing the prototypes of the functions and other for storing the actual code. The reason behind that is the header files like stdio.h consist of only declarations of the functions. That tells your compiler which functions you are going to use in your program. And your preprocessor simply combines those declarations with your actual source code and produce expanded source code. On the other hand, C standard library consists of actual definitions of the functions. Now, there is a program called linker which actually maps down the prototypes mentioned by the preprocessor to the actual codes written in the standard library. It simply maps and does not copy paste of the content like preprocessor. This separate process of linking makes computation of program little faster. Imagine if preprocessor does the job of adding all the actual definitions of the functions to the source code. How hectic the task would be, and it also increases the size of code exponentially because this time you're adding actual definitions and not the prototypes. And thus compiler has to do a lot of work to compile the program, and therefore speed of compilation drastically fall down. Therefore, maintaining header files and standard libraries separately is essential. Okay friends, we end the session now. But before you leave, here is a quick exercise for you. Install the code blocks and try to execute the code on your own that we had written. Make these changes to the code and see what happens. Please make changes one by one and not all at the same time to actually know what happens to the code, and we will able to see the errors clearly. Comment out the #includestdio.h. Second thing, remove the semicolon after printf. Remove int return type from main. Instead of 0 in return, write any integer value you want. Replace 0 with some character. Characters are usually written with single quotes. For example, you may write return A. Remove semicolon after return. The errors are shown in the window below. Over here you can see. Under this build messages tab. If there is any error, it will shown over here. As you can see, build is finished. 0 errors, 0 warnings and 0 minutes with 2 seconds. Right? So your code is completed successfully. Kindly see the message generated by the compiler and try to understand them on your own. That's it. See you in the next lecture. Bye-bye.